So
It's so
this
true.
conversation just sparked something in me. I always say like coding is communication as far
Hmm.
as like communicating to other developers.
Hmm.
But it's not just that though, because welcome to the LabVIEW experiment. I'm your host, Sam Taggart from SAS Workshops. If you're a developer looking to unlock your potential and take your skills to the next level, then look no further. From freeing your imagination and experimenting with new ideas and workflows, to exploring aspects of software development you've never even considered before, I'm going to help you grow your craft so you can approach your work like an artist and have more fun with what you do. In my 15 years working with and training developers, I've helped dozens of individuals and organizations embrace a growth and learning mindset that allows us to overcome challenges and embrace failure as the essential learning experience it is. If you're ready for the philosophies, strategies, tips, and tricks that will unlock your creativity, then it's time to get to work. All right, well, welcome back to the LabVIEW Experiment Podcast. I am Sam Taggart, the host, and I'm here with Alan C. Smith.
Hi. I am so glad to be here, Sam. This is awesome that you're doing this. Do I need to say something about who I am? Does your audience see?
I've been kind of assuming that everybody knows who you are, especially since the story you told me about how you showed up in Madrid and, didn't know anybody. And you're like, I'm sorry, I don't have my name tag. And they're like, we know exactly who you are. But yes, so let me do a little introduction first.
Okay.
So I've known Alan for what, 10 years
Heavens.
now? A long
Yeah,
time.
probably.
Yeah.
I don't even know.
Yeah. So I think first time I found out about Alan was through the actor framework, probably. I mean, that's what he's most well known for throughout the community. But that's not the start of your story, though. Right? You did a lot of stuff before that, and I think we should talk about that. But I knew Alan and Steven through the actor framework and going to CLA summits and everything. And Alan's a very good presenter, very prolific presenter, presenting at GDevCon in Europe.
Yes,
in Amsterdam.
I will be in Amsterdam next month.
Yeah, and presented here at GDevCon NA,
which was also awesome.
Yeah, we just finished. So
GDevCon NA is an awesome conference, and if you are serious about your LabVIEW skills and connecting with the LabVIEW community, I would encourage you. It's why I sponsor. You absolutely should put this on the radar to consider.
Yeah. So you've got a really cool story that you want to tell us. But before you get to that, why don't you just tell us a little bit more about your background in your own words?
Okay, so I have been, I'm going to totally date myself here. I have been doing this for 29 years at this point. I started in, 1993 with my very first bit of LabVIEW was the demo discs for LabVIEW 252, which is like a dozen, 3.5-inch floppies. And the first version that I did real production code in was LabVIEW 3. And I've been, I've started as a consultant. I happened to graduate into a terrible job market, and LabVIEW was there waiting for me. And there was such a need for LabVIEW developers that's where my career started. And I was 10 years as a contractor consultant.
And were you doing that on your own or for some kind of company? Or?
I initially had another consultant that you take your first opportunities where they come and you roll with them, even if you're kind of weird. There was a fellow at Bayer Pharmaceuticals in California that wanted to hire me because I was just a smart kid who got things done, and he wanted people like that on his team, but he couldn't because he had a hiring freeze on. But he had a subcontractor. He had a contractor who could hire subcontractors. And so that's how Phil Ewan got me on his team, working with my good friend Carl Chen, who is now long retired. And they brought me in as a contractor, fresh out of school, right? My brand new degree in physics. And what do you do with your brand new degree and your bachelor's degree in physics if you're not going to grad school? Well, in 1992, you write software. So I wound up doing software related tasks for these folks, and like this is good for now, but I better shore this up or it's not going to last. And I found LabVIEW in the course of doing that, and started my first LabVIEW projects were with Bayer, and then I started moving on because the Bay Area, I was in San Francisco Bay Area at the time, and it was, the amount of work available was prodigious, so much so that if you got known in the community as somebody who at least knew how to figure things out, there was plenty of work. And that kept me busy for about 10 years. And then I got done with California if anybody wants to meet me in private, I have all kinds of reasons why California was just no longer a good fit. And so I went to, I was an alliance partner the whole time that I was out there, because that was really early in the program and they needed consulting partners. And so Bill Harrell brought me in 95, I want to say. I went to my first NI week in 96. Then fast forward until about 2003, and I just hit one of those rough patches in your consulting practice where it's like, yeah, this isn't working. And California wasn't working for me. And I took a job with VI Engineering in Minnesota. Minnesota's a lovely state. St. Paul's a lovely area. That job was a terrible fit. It just didn't work in that environment. But I wound up after that working for a company in New Mexico that was a prime vendor for Sandia National Labs. And I got to do some pretty cool projects while I was there. One that was actually quite large. And you're going to ask me about that later. I'll tell that story when the time comes. Just an incident, things didn't go right in that. But it was probably the biggest thing I've ever done was that project. It was really cool. Did my 5 years in New Mexico. Decided, got married, my wife and I decided that we didn't want to stay in New Mexico, wanted to raise our kids elsewhere. And so we came to Austin, interestingly enough, pursuing my wife's career, because a LabVIEW career is pretty portable and my wife's wasn't. So we came to the Austin area and I got hired on to NI a little while after that, did 6 years in systems engineering at NI, which was an incredibly broadening experience. It got me involved. I actually got hired because I was helping Stephen with Actor Framework on the side as just something that, it was a model for how to build LabVIEW applications that I'd done some stuff that was very, very similar. We were doing actor programming long before we had the Actor Framework in LabVIEW. And so Stephen and I got to working on these incredible ideas he had for Actor Framework. I helped him turn that into something that engineers can use. We moved on from there. While I was doing that brought me to NI's attention. I got hired into systems engineering. When I wasn't helping customers figure out if they could use LabVIEW to solve their problem, I was helping out with Actor Framework, up to and including writing all of the AF tools that we use. I think I'm the only systems engineer that had direct bull privileges into LabVIEW, which was just really awesome, working with Darren Nattinger to get those tools put in. So that was a lot of fun and led to a lot of exposure, because that's where I was doing, all of my really prolific presentations whenever I can. I really enjoy. I'm an old theater guy, so it's always fun to get up and do that. And it's one thing to do theater and tell a story, and it's another to get up and here, let me help you be better, right? I figured out how to do something cool. And I'm gonna show you how to do that so you can do cool things. I love that. I found that I wouldn't want to do it full time because I love being an engineer, and I really enjoy teaching as essentially a side gig, as a thing that I learn a lot teaching. I've taught a lot of Actor Framework, and I've learned a lot about Actor Framework from teaching it to other people. I've been teaching the OO course, and I've actually gone back and I've started teaching some of the core stuff too, occasionally as time permits. That gets less priority from me. But I've taught a few Core 1, Core 2 courses, and that's interesting, because you go back and you look at the fundamentals. You're always going back to the fundamentals when you do something. It was a great opportunity to go back and look at fundamentals. And, oh, wow, there's things that got into LabVIEW that I never looked at because, when do you get to some of these things if you've got your techniques for doing things?
The craziest thing I ever noticed in one of those classes was the formats to string that you can double click on it and it opened up a dialog box. Did you know that?
No.
Where you put in the %F and all that stuff. Try double clicking on it. I didn't know it either. I was teaching the class and they showed that. I was like, wait, where'd this? I turned the page in the slides. I was like, where'd this dialogue come from?
Oh my goodness! It's like today when Casey was up talking about Bowser, which is this fabulous tool that the AF Guild put together. You can ask me about the AF Guild in a second.
Yeah.
But the AF Guild, new organization. We're all AF enthusiasts. We know how cool Actor Framework is. There's a lot of of fear, uncertainty, and doubt involved for people trying to get into AF, and we want to help people get over that hurdle. And if you choose to do something else, that's fine, but choose to do something else, with your eyes open, not because you're intimidated by the thing.
Yeah, well, you're lowering the barrier to entry, which is good.
Bingo. Yeah. And then you can, with that barrier lowered, you can decide which path you want to take based on good knowledge. That's just us making you better. But they're putting together the other folks involved with the
AF Guild.
With the thank you. It's been I went tubing with Sam. I just spent 2 hours floating down the creek over here in Golden, and it's just a little too much sun. But so they're putting in this tool called Bowser, which is it's basically a navigation tool for giving you something closer to working with queued, with queued message handlers. Everything's right there on the block diagram. You lose that with Active Framework for a lot of really good reasons. And this browser tool is a way to get you something like that browsing through the code experience. You're never going to be on that block diagram again. And we can talk about some ways about why thinking about just one block diagram is a little limiting.
There's some issues with that, yeah.
But having tools that help you when you're no longer programming just on the block diagram, and it's fabulous. I'm excited to see that tool, and I'm really glad that we're putting that together.
Well, I know for me personally, that lowers a lot of my dislike of I want to say dislike, my apprehension about using
your concerns.
And also, I think too, it helps you to bring new people on, because one of the things with Active Framework, right, is that it requires a certain level of skill, and bringing new people on can be a challenge, but that will lower that barrier.
Oh yeah. I think so.
Even if like you're the engineer and the architect and you don't need that low barrier lowered, if you're going to pass it off to somebody else who's a little less skilled, that's nice to have that barrier.
And even as a really experienced AF person, sometimes I really do just want to be able to flip through all the cases. But Casey's like showing up that thing, and he's like, and oh, by the way, you're in a queued message handler, and you can hold down the control and hit your mouse wheel and flip through the case, scroll through the cases on a case structure. Yeah. I'm sorry, what? Darren Naniger was sitting next to me like, when did we get that?
Darren said that?
No, I said that. Okay. I said that. And he's like, it's been there a while.
About that, yeah. No, that's actually been there a while, but I had the same reaction when I discovered it. I was like, wow, that's really great.
When you've been doing it, doing anything as long as I have, things come into the product and you miss it.
Well, part of it is because you're not always necessarily working with the latest version either when it first comes out. And by the time you get there, like all the hype around the new features has kind of died down. And so,
I finally have one of my customers working in LabVIEW 2021.
That's good.
After 3 years of 2016 and 2017, and like there's all this cool stuff I want to work with. And
I've kind of set the bar at like 2020 for now, because I like VIMs, and even though Darren is like, there's some rusty nails there, but I like the VIMs and I like the interfaces, and your presentation on sets and maps is great because I think they are underutilized and not as well understood.
Yeah,
I think they have a lot of utility.
They are. And this is old dog do tricks kind of thing, right? I had, as I said in my presentation, when you can watch the presentation when the GDevCon stuff recordings get posted. But I did this presentation and people are coming up to me asking me other sets and maps questions, and I'm like, guys, this was the first time I got to play with them and do something really interesting, as opposed to just a quick replacement for a variant attribute table or something. And I did a couple of those, and that's valuable, right? But then putting sets and maps together and coming up with a complex searchable data structure, and I'm sure I'm a software engineer. I'm sure a computer scientist could give me like 15 ways to make that even cooler. but just here me looking at it and going, oh wow, I can put these two things together, and that was the whole gist of my presentation was that we pull together some things we don't normally think about and come up with something that's interesting. But that was my first foray into sets and maps, and I'm looking forward to adding that to my arsenal of tools to bring to solving problems. And it's like, wow, they didn't come in with much fanfare. They announced them. Hey, we got sets and maps in 2019. Okay, that's cool. Oh, we got interfaces in next year. I was so much more excited about that I didn't. And I kind of that's kind of neat. But now it's like, oh, that's really, that's gonna. Interfaces are awesome. They're everything we say they are, and sets and maps are going to be one of those utility things that just keep giving us dividends over and over again without being really flashy.
Yeah, they're underappreciated.
Yeah, I think you're right about that.
Well, so my recommendation, I think I told you this, if you want to learn sets of maps, is to go solve some of the Advent of Code challenges, because a lot of those well, I wouldn't say they require, because people solve them without them, but they make it a lot easier.
Right, and that's what these are.
Yeah.
I mean, LabVIEW's been a lot of, and the productivity tools are incredibly valuable. A lot of what we've been getting for LabVIEW in the last few years has been productivity tools. Having a language addition like interfaces or sets and maps, those have gotten rarer. Just because, I mean, LabVIEW's pretty mature. We've got pretty much all we need. Not quite everything, but we've got a lot of what we need. So we don't have necessarily, we don't get a lot of new language features very often. And
I'm sure Steven still has a list. I know he told me once he had one more thing on his list, and I forget what it was, but interfaces was getting close to the top of his list.
Yeah. I'm just really, check out the proceedings from GDevCon in Europe. We've already published a lot. I've already spoken some about interfaces in a couple of different environments. Steven has spoken a bunch. But I'm going to be talking. I don't want to give the show away here, right? But I'm going to be talking about interfaces really change how we're going to look at actor framework systems. It's not, and it's an interesting shift because it is profound and not paradigm changing. So it's not
profound in the amount of work it saves you
profound in the amount of work that it saves us, and profound in what it's going to do to our designs. But that's what I'm going to be talking about.
Oh no,
but
I think it's really cool.
It's still Actor Framework. It's still the same framework we've been using for the last 10 years.
Yeah.
It's just that we make these couple of shifts, and a real obvious thing like no longer needing abstract messages. That's an obvious win that everybody's going to pick up, which is not unlike going, a map is just a replacement for a variant attribute table. And that is absolutely true. And it really doesn't go beyond that, except that you're going to do all these really amazing things.
Well, the thing I noticed with interfaces and actor framework, and if you touch on this, I don't want to spoil your thing, but that you can have an actor that has multiple interfaces.
Oh yeah.
Which is really cool, because with abstract messages, you just had all the abstract messages, but you couldn't quarter them off and say this set of abstract messages or that set. But now with the interface, you can say this interface or that interface. You can use one or the other. That's an interesting.
So at the risk of getting a mob of pitchfork and torch wielding LabVIEW aficionados in front of my house, actor frameworks, abstract messages and actor framework, that was my biggest single contribution to the design. I got a phone call from Steven as we were working on it. And he's like, we can't use this because we can't decouple, caller from nested. And that was the thing that came to mind. It's like, we can do these abstract messages. We can do this dependency injection as a way of dealing with that. And we latched onto that. And it is on its technical merits, it is a good solution.
Yep.
Okay. It confused the hell out of a lot of people. And I will confess to being puzzled by this. And it's just, I've learned to accept it. It's just my brain works and could see it. And a lot of other people, I have to work to get them there. I can get anybody to understanding abstract messages, but it takes some varying amount of work to get there, which kind of surprised me. But I think you'd asked me at one point to think about some of the mistakes that I've made, things that I've learned from. One of the things that I count as kind of a significant mistake is that we, in the tooling, required that abstract messages be linked to a specific sending actor. And if I figured out not too long before interfaces were announced, I figured out that really, no, we should be just making abstract messages and putting them in their own library. And then they would have been very much like interfaces in how we could use them.
Libraries,
And I could have this actor calling on these two different libraries to send abstracts where they needed to go. But yes, the different interfaces, having multiple interfaces on an actor means you can have libraries of interfaces that you use. It means that you can really kind of, and then we say this in the revision of the actor framework course, there's a new version of the AF course that does interfaces, right? And one of the things we say that's in this course, and I'm not giving anything away because it's in the course, is that an interface is how class A talks to class B, or actor A talks to actor B, and it is system specific. It is not the general solution for all time. You write your interfaces for the problem you're solving, and your classes are your classes with their default behavior. And bringing that to Actor Framework, I think, is going to really change how we look at a number of things, mostly having to do with reuse. And a lot of the reuse potential. Actor Framework has always been about reuse.
Yep.
And reuse in a community environment as well. I'd love to see more developers doing things like the network endpoints, which are, I have a solution to, like design patterns, right? I have a solution to a coding problem that we always have. Here's an actor, drop it in your system and use it. Interfaces are going to make that much more viable, a proposition.
Yeah, because you could adapt it to your specific caller. Because you're right, and following your packaging principles. I want to make sure I understood this correctly.
The Robert Martin's packaging principles,
your packaging principles presentation, right? Which comes from the book, right?
Yeah.
The interface then would be packaged with the caller, the person that's using it.
If it's not in its own package.
Yeah.
If it's not in its own, because it could be.
It could be, yeah.
The interfaces could be foundational.
Yep.
And you could just say, I'm defining all the interfaces to my system, and they're all in their packages. And now this caller is going to call from this library. Yep. But yeah, they are much more strongly linked to their caller than the receiver.
Yep.
Which is true of no, right now we turn it around, because right now the messages are more closely tied to receiver. And this is going to be, this is what I'm going to get into in Amsterdam. So when that video becomes available, if you can't join us in Amsterdam, and I think it's going to be a fabulous time if you can, but that's a heavy lift. If you can't join us in Amsterdam, watch further proceeds on that. I've seen the presentation list, the agenda for GDevCon is just really amazing. So that's definitely going to be another one to watch. And I'm really excited that we, as LabVIEW aficionados, that we own this space now with GDevCon NA and GDevCon in Europe. I think these things are really important. Full disclosure, I am a sponsor of GDevCon NA, and I am a sponsor of GDevCon in Europe.
Full disclosure, so am I. So
really, I hadn't realized. Yeah,
and I'm also president of GDevCon NA.
Right.
Yeah.
No, I think these things are so important. And even when NI was running, was doing CLA summits and NI weeks with these kinds of contents, I think it was still important to have these outlets. And then, now that NI's pulled back, they're critical.
Yeah. So we were talking about the importance of the conferences. Mm-hmm. So I think that part of the importance of the conferences, like we're talking about interfaces now, right? They're new, at least in the LabVIEW world. And so I think part of that is figuring out how best to use them and what the advantages are and all that. I think that comes out in discussions like this and listening to your presentations and you listening to other people's presentations, and they influence each other and bounce ideas back and forth, and the conversation afterward.
I realize this about myself. One of the reasons I do so many presentations is this is actually how I master a concept. When you're teaching somebody to do something, you tell them how to do it, and then you show them how to do it, and then you make them do it, and then you make them teach somebody else. And it really is that last step that locks it down for the presenter. And then, there's so much more to it, because I can throw an idea out into an environment, and we saw several fabulous ideas this week, and they're going to get talked about in conversation, which are going to lead to other realizations of things that we can do, and other concepts are going to come to the fore because we've had these conversations. I read something not too long ago about a conversation, putting things into words as a critical part of cognition, as a critical part of actually thinking about something, which made me wandering around my house muttering to myself about concepts suddenly a lot more palatable. My wife is like, she's just used to me doing that.
Was it my blog? Because I posted something recently. I read the book Thinking in Systems, and I had a quote, something about, we don't talk about what we see what we talk about.
Really?
Does that sound familiar? Because that's right along those
Thinking in
veins.
Systems. I think maybe I need to read this.
Yeah, it's a very interesting book because, you know, I think systems, I'm an electrical engineer.
Mhm.
I think like signals and systems, and I think like in numerical analysis and, you know, feedback loops and Laplace transforms and all this stuff. And it talks about systems as far as like systems of humans. Because
Mhm.
like when we modeled stuff, we never really modeled humans, right? Like
Right.
we had a person in the loop and maybe we modeled them as a delay, like how long will it take the driver to react?
Right.
But that was it.
Right.
And obviously human beings are so much more complicated.
Right. We normally leave the modeling of human behavior to economists.
Yeah. Yeah. Well, these were like models of like governments and economies and, you know, judicial systems and all this stuff. And they used no math, but it was, the way they explained it, you got this like intuitive sense of what was going on. It was really interesting.
Okay.
And it was really a book about societal and organizational change, about realizing the systems that are in place that we've built out of human beings and how we interact with each other,
Mhm.
and then figuring out where are the touch points that you can touch to change things and influence the output.
Interesting.
And I thought it was very, very interesting. So like, you know, it has implications like a societal level, but like if you work in a company,
Mhm.
like even just like your relationship with your clients, a relationship with NI, like that whole
Mhm.
thing, it's all a system.
Right.
And it's
And
about
it all scales, right? I
Yeah.
mean, you know,
we build systems upon systems
Yeah.
and yeah. And so, you know, it would be actually really interesting to go back and look at that book and try to like model like relationship with clients, relationship with NI, and like see how like where the touch points are.
okay, I have to look at that.
Yeah, and it's thin and it's pretty quick reading.
Okay.
And it's very, if you're interested in like societal stuff and psychology and like those type of things and human interaction, it's really interesting.
I have gotten a lot more interested as my career has progressed. Somebody I worked with back in New Mexico once pointed out to me that, you know, we write software and we think we're writing software we're going to acquire some data and we're going to do some analysis and we're going to do this. Okay, those are the things that we need to do, but the purpose of the software is to change somebody's workflow. Right? We are going to change how people work. Hopefully for the better, hopefully in a way that makes them happier to come to work every day, or at least less distressed about it. And we had a presentation on UI and telling a story, and fits right in with that. Right?
Yeah, that was a great presentation.
Yeah, that was an awesome one.
I highly recommend going and watching that.
That was Hunter's. That was Hunter
Yep.
Smith's, right? Yeah,
Yep.
go look him up. That was a really good. You know, I mean, we write our software for human beings.
Yep.
And we're trying to make their lives better in some way.
Yeah.
And that's really important. And I've had customers, having realized that, it gets really frustrating when you're working with a customer and the end client doesn't. I mean, I had one end client. I was saying, we've got a real opportunity to make these operators' lives better. And the end client, I won't say who for, you know, obvious reasons, but the end client was like, my operators will do what I tell them to do.
Yeah, I bet they're very happy operators.
Yeah, and I know the environment they're in, and yeah, that's just so counterproductive.
Yeah.
And I'm not arguing this from some altruistic point of view of, you know, we like happy workers because we like people to be happy. We like happy workers because they get our stuff done.
Well, they work harder and they're willing to stay
Yeah.
late, and yeah.
It's, you know, I a long time ago, and it was just some silly little button that I picked up in Austin on 6th Street, and it says good karma is cost effective.
Yeah.
And I love that quote.
Yeah. So
It's
this
so true.
conversation just sparked something in me. I always say like coding is communication as far as like communicating to other developers.
Mhm.
But it's not just that though, because based off Hunter's UI stuff, it's communication not just to the developers, but also to the users, which is a very interesting like that I hadn't connected those two
the
things.
operators of the software,
Yeah.
and the end consumers of the work product of the software.
Yeah, exactly. Yeah, because it doesn't stop at the software, right?
Right,
If especially like, you know, the example I've used a couple times is like you're testing parts for a car or something. You're not just affecting the car, like you're affecting the test operators. You're affecting the car. You're affecting the people that buy the car. You're affecting the other people on the road with the car.
Mm-hmm. So you're
it's like a
affecting
whole
all of their
system.
customers,
Yeah.
and then you're affecting, you know,
Well, even
the
other
operators.
employees though, because other employees of the company, because if
Mhm.
they sell the car's a dud and they have to do a big recall, they're going to lay people off.
Mhm.
Even
Right.
people who had nothing to do with that car, and this affects the sales, and it's like a whole big system.
It affects the decision making of the management team.
Yep.
The data that they get back, can they believe it or not? I have another example from, and again, I won't mention the customer, but this is another example from my time at NI in systems engineering. SE was pre-sales technical support. Our mission was to demonstrate for you that NI products would solve your problem. And there was a whole lot of interest in the time. And this is where the semiconductor silo in NI came from, really was grew out of this. We were trying to capture business away from the big iron testers. And we were, this was not my team. This was my team, but I wasn't working with these folks. This is something that I heard about. We were trying to prove that we could do a certain test. And we were getting data that did not align with their legacy system. And we were trying. And our engineers kept going back and like looking at the science and looking at the engineering, really trying to understand where it was they were going wrong. And what they finally realized is that we weren't getting it wrong at all. The big iron tester was getting it wrong. And the customer says, well, you're always measuring something. And they've been making decisions based on this wrong data that they just hadn't realized was right. And so, you're affecting a whole lot of things with our software.
Yep.
Yeah.
Yeah. So you had a story that you want to tell. So I want to make sure we have time to cover that.
Okay. Yeah. This is probably the most catastrophic failure that I've had in my career. And it is so catastrophic that it involves multiple entities, multiple individuals from multiple organizations. And everybody had their little piece of it. So this goes back to the company was called K-Tech. They don't exist anymore. They got by Raytheon. But they were a prime vendor to Sandia National Laboratories. We were across the street. We were all hooked up to government contracts. We had badges that we could go on to Sandia pretty much when we needed to. And I was actually hired to help with this project. It was the thermal test complex. This is 2004, 2005. Thermal test complex. It was actually a congressional line item. You can go back to a congressional budget one year and you can find the line item to build this facility. It was a fire science facility. So they were lighting fires and burning stuff up and seeing what was happening. That was the mission. And the fire sciences lab and it was cool. I mean, this is big engineering because the building wasn't done when we started coding. The apparatus was still being built as we were coding up this system. So we were kind of just trying to keep we're like coming in right behind the installers as they were doing stuff. And I had to wear a hard hat and, steel-toed boots to go to work. And part of this facility, there were three different parts of the facility. And the one in question for this story had involved a wind tunnel. And so what they would do is they would fill a pan with jet fuel and hang the test article over the pan. And they would turn on this big, big monster 750 horsepower fan and suck air through across this burning, pan of jet fuel. And they would run their test and take all their data and see what happened and then look at the test article when they were done. 750 horsepower fan in a wind tunnel. And then the other part of it that they used to regulate airflow was this set of dampers, louvers, just would open and close. And they were simple mechanical devices. They would cut airflow. And this fan with the louvers open and this fan going full out would move like 400,000 cubic feet per minute of air. It was spectacular. And it was so strong that if the dampers closed, they would be ripped off the wall.
And would they get sucked into the fan or something?
Well, the fan was like way down range, and they'd come off the wall and they'd fall down because suddenly your airflow your pressure would go to zero because now you have a big hole in the wall. Okay. And so then we knew this going in. We knew that there were hazards there, and so we had a design specification that laid out here's the procedure for how we want spinning the fan up and opening the louvers. And this is all about, this is all supposed to wind up in software. And this was all supposed to be about, making sure that we never got into that situation where the fan was full out and the louvers were closed. And we wrote our code to manage all of that stuff. And we were installed and the operators were running tests. And we're going along our merry way. We're working on additional software changes, and we're doing the paperwork, dotting our I's and crossing the T's, and we get a phone call from the fire science facility that we needed to come over because something had gone really wrong. Oh, okay, all right. So my partner Kevin Ward, a good guy, he and I and our managers, we got in our cars and we drove over to the facility, and the engineer, I can't remember his name now, that we were one of our Sandia contacts, says, all right, he walks us over there. He says, I'm going to open this door. Do not walk into the room. And he opens the door, and we had ripped like 2/3 of the dampers off the wall, and they are sprawled out on the floor in front of us, and it is just a mound of twisted, jagged metal, and of the dampers that were left on the wall. Some of them are just hanging there, and some of them are deformed. A couple of them were okay, but the damage was just really impressive, right? And I mean, some of us are just like horrified, and some of them, myself included, how you deal with stress is kind of depends on you as an individual, and several of us were actually just kind of laughing in awe at this disaster. I mean, nobody got hurt, right?
Yeah,
no one was injured.
Absolutely.
That's like the big important thing. Nobody got hurt. It was just stuff.
Property damage.
It's just property damage. So no one was running around like missing limbs or cut up or anything. And some of us were just laughing from the stress of this, because you can laugh or you can cry. Those are your two choices. And some people cry and some people laugh, and you don't actually get a say in how you're going to respond. Right?
The reaction.
$175,000 worth of damage on a project that was, we were going to get $500,000 to do the coding work. And of course we were, everything was over budget, and we were going back and forth with Sandia and adjusting the compensation we were going to get and stuff. But we're looking at this is bad news. This is you potentially clean out your desk level of bad news, right? And if you've ever worked at I don't know if this is true for every national lab. I've worked with 3 of them over my career, and Sandia is very risk averse, and very much when something goes wrong, they want to find an individual that's responsible for what's wrong. That's a part of, I think, they're required as a government entity. They're required to have some pretty strict accountability. So they're looking at us, and they're looking at us to come up with fixing this. All right, well, it's time to go to work. It's time to go do a different kind of work. What the hell just happened, right? And because didn't we code all this stuff to prevent this? And so we entered into basically a 2-week-long forensic analysis of what went wrong, and I don't believe in avoiding accountability. I do believe very much that everybody should own their part of it and should make their part of it right.
Yep.
But not. It's not about pointing fingers. It's about stepping up and taking, and if everybody steps up and takes the appropriate level of responsibility, then when you're done, everybody's going to be basically whole. Okay. So we go digging into this, and we did find, and I had 2 weeks of LabVIEW DSC, data logging supervisory control toolkit data on all of our system tags related to that system. So I knew when the fan had been set to certain values. I knew the state of the dampers. I knew how much air we were moving. I had all of that information. I didn't quite have everything I needed, but I had a lot of it. And we had interviews with the operators, and then we had, of course, our own code to look at. And interestingly enough, my wife has a background in investigations, so I kind of leaned on her a little bit for how to talk to the operators and get them to tell me truthfully what had happened.
Yeah, I imagine there was a little reluctance.
Oh yeah, well when you're thinking that your boss is looking for somebody to blame, you're not going to be you're going to take a moment and get your story straight.
Yeah, not a lot of psychological safety.
Right, not a lot of it's not safe to own your stuff. And I actually don't think the operators were really to blame at all for what happened. They had a part in it, but it was a perfectly normal, reasonable response. So what we found after looking at all of this stuff was we did find a bug in our software. Okay, what we found was a condition, and it was a conflict in the requirements that we didn't catch that there was a conflict. And so we coded what was in front of us. And then I think there was actually also an actual programming mistake. And it was on the order of, some of your listeners who are old enough may remember that the Hubble telescope was, actually needed some vision correction after it was launched because somebody somewhere inverted a sign on an integer. A 1 became a -1, and it was that simple. And now they had this telescope they had to fix. And we had something along those lines. It was a straightforward, anybody can make that mistake coding error. But that's on us. We did that. Okay. And then looking at it, and so what happened was this coding error meant that the fan ran up to 400,000 cubic feet per minute, full speed. All the dampers were open. Now that ran for a period of time. And that, as it turns out, was perfectly safe. But we had operators with a brand new system that they had no operational experience on. And they had an unusual situation. And because it was brand new, they had no guidance on the correct response. And then we found the other problem with the system because they ordered the fan speed to 0 and all the dampers closed. And the fan does not respond instantaneously. And there was nothing in the requirements about how to step down if we had to suddenly stop the fan. How long is the fan going to spin down? What should be the step down procedure for the louvers? What's the crash stop? And so the operators did a not unreasonable thing. They did the obvious thing. Let's shut this down. This is not an outrage. This is out of control condition. Let's shut it down. And that took the dampers off the wall. And this is, as just about all accidents are, a chain of unfortunate things that led to something pretty catastrophic. And to my money, brand new system. I mean, there's a reason. One of the guys on the Sandia team was fond of saying there's a reason we call it research, right? Nobody had ever built one of these before. Yep. And so we had guys in a situation that nobody was prepared for, and they did the reasonable thing, and it turned out to be a problem. So things that came out of this, anybody who knows me knows what I think about requirements documents, which is not terribly favorable.
Okay, so you probably agree with me.
Yeah. They're conversation starters.
They're not. Yeah, it needs to be a living document, and you need to revisit it, and you need to be able to change it, and you need to have some agreement and be on the same page too. Because even though you write something down, I might understand something different, and we need to have that communication. Yeah. And
but when I came into K-Tech, they had already been talking over requirements for quite a while. And I got there and we spent another 3 or 4 months talking about requirements. They had talked for 2 years.
Without actually building anything.
Without
actually
long enough that the hardware they had selected had become, mature, and the next thing they should be using had come out, but they couldn't make that upgrade. So the requirements
you're missing out on all that learning from the time you start the project till you finish it. You're learning so much, and it's gone because the requirements are fixed before you know anything about the problem.
The requirements should all have been about the test articles and the tests they need to complete. And we should have recognized, we should have recognized that things aren't going to be complete. Everybody involved, we talked about this for 2 years.
Yep.
And nobody caught that they needed a step down. Nobody. And I didn't either. Right? I'm not holding myself above this. My partner didn't, I didn't, none of the Sandians did. Oh, what's our crash stop? Not specified anywhere because human beings, software is a hard problem. These are hard problems, and you're not going to know the answer until you've solved it. So we had that going on. Really having the good data was really critical, because if we hadn't had that, we'd have written a $175,000 check, which would have been just catastrophic to the project. I looked at that situation, and really, the operators wound up taking the blame, and I thought that was a horrible injustice because. Really, honestly, everybody was doing their best, and things happen, and at some level, societally and as engineers, we need to recognize that. It's one of the things that I admire about an organization like SpaceX. They test their rockets until they blow up, and then they learn from that, and then they go build more rockets. And I think that's a much healthier approach, as long as nobody gets hurt, right?
Yeah,
it's just stuff.
Yeah, well, it's embracing this.
Yeah.
I don't want to call it failure, but it's embracing going out and trying things and knowing that it's not going to work, but you design the experiment in such a way that you put guardrails on it so that even if it blows up, like nobody's around, so it doesn't matter. It's just stuff, and then you go back.
And we learn.
Yeah.
And we learn. And we did. We went in and we fixed our bug, and there was no additional charge to go fix our stuff and test it. I was not as aware of this was coming up on 2 decades ago, so I was less aware of the importance of unit testing. So all of our testing was hand testing at that time. And so that's another takeaway from all of this is really honestly unit test these things as best you can, not just because it proves your code works, but because writing the unit test is instructive.
So though a unit test, I don't know would that have caught that, because that seems like more of an integration issue. Yeah.
No,
it's multiple.
It probably would have caught the bug that drove us to the runaway condition.
Yeah, that it would have caught.
Yeah, it would have caught that part.
Which probably would that was probably like the start of the chain.
Mm-hmm. That was absolutely
the
start of the chain.
But it's not the only. Yeah,
and it's why they were looking at us.
But
it's why they were looking at us, because that should not have happened.
Yep.
Right. But it did.
Yeah. The other thought I had on all this, though, is thinking about Hunter's presentation, go back to the UI stuff, about not just communicating information, but what do you do with that information, right? And if you had could you have designed it better so that the indicator on the fan, you don't just set the speed, but like you can watch it ramp down, and like, okay, now it's in the green zone. Okay, now I can shut down the.
Yeah. Well, and that goes to what do you tell your operators? Could we have built something in the UI to tell them how to step the fans down, or what the stop, what is the, we really needed to have an algorithm for stopping that fan in a hurry, and we just didn't, because nobody caught it.
Well, the other thing is, though, too, and I mentioned this when we first mentioned this, like my mind initially jumped to don't do that in software, like have some kind of mechanical, like I'm always a fan of mechanical interlocks and stuff. Like anytime, like all the limits in software should be like soft limits, like the hard limit should be mechanical stop or something like that.
I absolutely agree with you, right? Your e-stop should be, an actual electrical signal in your system, and then the software should play catch up if the e-stop gets triggered, or a mechanical stop if you have one. I would have to it would be an interesting conversation with the mechanical engineer, because that fan was tens. So there was actually an L turn. Part of the reason the fans, I think you asked me earlier when I was outlining the story for you, the fan material didn't get sucked down, partly because as soon as they came off the wall, the pressure dropped, but also partly because there was a 90-degree bend. Mm-hmm. And when they got pulled off the wall, they fell down on the floor and not toward the fan. The fan would have pulled them 90 degrees. But that fan was tens of yards away. Mm-hmm. So I'm not sure what kind of mechanical linkage you could build in. Now, maybe if you did something, electrical with a local FPGA or something, and you're driving that would probably, that would, what's the current coming off the fan? I don't know how we could have built it in that scenario, but yeah, something not.
Yeah, I have no idea.
Specific, not high level software specific.
Yeah, it just occurred to me as like that would be a better solution if there was some way to do it. But yeah, I'm not a mechanical engineer either. So
and this project had a number of things like that. It's like, well, why are we doing this in software instead of this way? Well, because nobody thought to put in the requirements document, and the budget's fixed, and there you go. We're not doing it. Yeah. So, and that happens. It's not specific to this customer. I've seen that in a lot of places. I have one of my recent projects, it's like, I really want the e-stop to just be an electrical signal and not something that I have to relay.
Well, I had a very interesting project where they were doing sputtering, and it's basically you have 2 electrodes in a vacuum, and you inject gases, and it like particles migrate, and it like basically does like some kind of coating.
Okay.
On metal parts.
Oh yeah. Okay. Yeah. And electrolysis machine.
So, but it's kind of like that. The guy wanted me. They had an interlock to prevent you from turning on the oxygen when the thing was going, because it could blow up. Right?
Oh yeah. Add oxygen to heat.
But it was something about. It was in the software, and like when you hit the button for something else, disable the control to turn on the oxygen. That was their level of interlock. And there's a note in the code that said, don't do this because it could cause fire or whatever. Right? So they wanted me to remove this interlock. They didn't tell me why the interlock existed or anything. And I opened up the code, and I'm looking at it, and it's like, when this switch toggles, toggle the oxygen off, or disable the oxygen toggle. And I'm looking at it, and I'm like, well, hey, the way this is implemented is not the greatest. And I was like, you want me to go change this? I was like, I wrote back to the guy. I said, I will change this if you send me a letter from your CEO that says, I have
I'm not
permission to change
responsible.
this and I am not responsible for whatever happens.
Yeah, and I'm thinking the answer is simply no. Coworker of mine at NI, Guy McDonald, another longtime experienced developer before he went to NI, he actually told me once a story about it, and I won't go into his story because it's his, but one customer he was working with, where he got up and walked out of the room because he says, I'm not going to do this because I'm not going to help you fail. I mean, we do have, as engineers, we have ethical responsibility to avoid doing the really stupid things.
Yeah.
And sometimes you walk away.
Yeah. Well, you need to have a culture that allows that, because otherwise you end up with the malicious compliance thing where they're like, oh, go do this. And you're like, well, that's going to drive the bus off the cliff. And they're like, well, no, go do it. And you're like, okay. Like,
one bus wreck coming up.
Yeah. So very interesting stuff. It's been a great conversation, Alan. I really enjoyed it.
Yeah, me too.
Yeah.
It's fun to reminisce.
Yeah.
And always good to talk to you, Sam. Always good to talk to you. Hopefully, I don't know if you'll make it to Amsterdam, but if not, I'm sure we'll be in touch.
I'm certainly going to try, and I'm going to bring my videographer and podcast producer Steven along with me, and if I can, maybe we'll even do another episode.
Thanks for doing this, Steven. Thanks for all the setup and stuff. We'll give him a shout out here. He's done a great job setting us up here.
Yeah, and he also did all the video and audio stuff for GDevCon NA and all the photos, and he did an amazing job. So he definitely deserves a lot of credit.
Last year's looked really good, and I'm looking forward to seeing what this year.
This year's going to be even better. We had a separate assistant to help him get some shots, and we had extra cameras. So it's gonna be great.
Oh yeah, I saw you guys moving around. It's fabulous stuff.
All right, great. All right. Thank you, Alan.
Sam. Thanks, Sam.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment so you never miss an episode. And remember, small steps and quick feedback are all you need. Catch you next time.